Hi everyone. The purpose of this video is to give you an overview of CIS 351 and how I approach teaching it. The first thing you should know is that I make very little use of Blackboard. It simply doesn't provide the tools and workflow I need to efficiently run this class. Instead, your primary resource for this course is going to be my GVSU webpage. You can see the URL here in the taskbar, and I'll be sure to include it below in the comments. If you look at the upper left in the navigation bar, you'll see a link for CIS 351. I encourage you to bookmark this page because you'll visit it a lot during the semester. On this page, you'll find all the information you expect. My contact information, office hours, a link to the syllabus, a list of assignments and labs, information about the textbook, and here at the bottom, you'll see a list of references that you might find helpful at different points throughout the semester. Perhaps the most important link on this page is the timeline. Again, the link is here in the navigation bar. The timeline will show you what I plan to cover each day. So if you ever miss class and you want to know what we did, look here first. If you need more details, of course, don't hesitate to email me, but at least look here before you do. The next thing you should know about this course is that most of it is flipped. What that means is I've moved most of the non-interactive content to videos and textbook readings. The idea is, why use valuable class time to just sit and watch me talk? A video will do the same thing, but you can do it at your convenience. And you can pause a video or rewind it, or I suppose you could even fast forward it. Well, speaking of fast forward, when you watch videos for this class, I suggest you set them to play back at 1 1/4 or 1 1/2 speed. I find that the pacing of my videos feels kind of slow when I listen to them. But if I try to talk faster when recording them, I end up tripping over my words. So, recording them at a comfortable pace, then having you play them back at your preferred listening speed seems to work best. Anyway, the main point is that watching a video is a more efficient and flexible use of your time than sitting in a classroom just listening to me lecture. Instead, we want to use class time for things that you can't easily do outside of class, like ask questions or have discussions. So here's the basic workflow. When looking at the timeline, you'll see a list of videos and readings that you should have completed before each lecture, including the first day of class. Next to many of these videos, there are links to sample quiz questions. I suggest you read through these questions first so you'll know what to look for as you watch the videos. Similarly, in the milestones column on the far right, you'll see links to homeworks and in-class activities. You might also want to look through these for the same reason. During class time, I'll answer questions over the videos, then help you work through the in-class activities. We may also work through some of the homework problems. But I'll make a point of letting you know in advance which homework problems we might work through in class so that you'll know to take some time beforehand to try them on your own. For example, I've indicated here that problems 2 through 8 might be discussed beginning Friday the 14th. I'll be using mastery grading in this course. Let me provide some context for those who aren't familiar. Most courses in the School of Computing use what I call the pile of points system. You collect points for every assignment and test, and your grade is a percentage of the points you accumulate over the semester. In my opinion, this system has 2 big flaws. First, consider this scenario. You're evaluating a new software product. Let's say it's a word processor, and let's assume that 85% of the features work flawlessly, but 15% are completely broken. Assuming the core features work, that is, users can load, edit, and save files, it seems reasonable to give this product a B. It'll work just fine for most potential customers. But what if every feature is only 85% correct? Is it still worth a B? Well, no, because it won't be useful for anybody. You can't effectively use a tool where every feature is buggy. Think about it this way. Who would you rather have on your senior project team? A student who can only do 85% of the tasks, but will do those tasks correctly? Or a student who always writes code that is only 85% correct, so no matter what you ask him to do, you'll have to go back and fix it? One of the key advantages of mastery grading is it distinguishes the first type of student from the second. Right? The first type of student clearly deserves a B. It's not clear whether the second student should even pass the class. The second problem with our traditional pile of points is that students who take a little longer to learn things often get grades that don't reflect everything they've learned over the course of the semester. For example, students who don't happen to have mastered, let's say, binary to decimal conversions by the first test end up with a lower grade, even if they happen to learn it a week or two later. Mastery grading fixes this problem because you get multiple attempts to demonstrate what you've learned. Your final grade more accurately reflects what you know at the end of the semester, rather than just showing you what you happen to have mastered by the time the test came along. Now, everybody does mastery grading a little bit differently. So what does it mean in this course? First, instead of points, I'll evaluate submissions using what Robert Talbert calls the EMPX Rubric. M means meets expectations. This is by and large your goal for everything you do in the course. I'll say a submission meets expectations if it's complete, has met all the requirements, and clearly demonstrates that you understand the underlying concepts. Your goal for all of your work is to eventually bring it to a level of an M, even if you have to fix and resubmit it. P means progressing. This means you're making good progress toward earning an M, but you haven't quite got there yet. X means not yet. So either the submission is incomplete, or maybe you just haven't turned it in, or this is a tougher thing for you and you just haven't made a lot of progress on it yet. Finally, E means excellent, or exceeds expectations. E's don't have any formal effect on your grade. In terms of getting your final letter grade, E's are as good as M's, but you can kind of think of them as a pat on the back for unusually good work. Your final grade is determined by this rubric, which is included in the syllabus. Notice that there are several categories. Your final grade is based on the number of M's in each category, not just the total number of M's. So bear with me while I say a few words about each category. The foundation of your grade is your success in mastering the course's learning objectives. These represent the skills that you've acquired over the course of the semester. There are 35 total learning objectives, ranging from things at the beginning like converting binary to decimal, all the way to the ending topics of like tracing cache hits and misses. You can see here that you need to master 31 of these objectives to get an A-, 26 to get a B, and so on. 16 of these objectives are considered core objectives. In some sense, these 16 objectives are what this course is all about. If you haven't mastered all 16 of these objectives, then you have a pretty big hole in your overall understanding of computer organization. Consider this analogy. Suppose you mastered all of the objectives in your Intro to Programming course except for loops. Even though you mastered everything else, loops are so fundamental to programming that it's impossible to justify awarding you a high grade for the course. Furthermore, if you can't effectively use loops, you really aren't ready for the next programming course, regardless of what your other programming skills are. You need to go back and fix that hole before moving on. So likewise, if you haven't mastered some of the core concepts for this course, then in my opinion, you're missing some of the fundamental knowledge that all computer scientists should have. That's why the requirements for this category are so high. You need to master at least 14 of the 16 core objectives to pass the course. This may seem like an absurdly high requirement, but remember, you get multiple chances to demonstrate mastery of each objective. It's not like one bad test will put you in danger of failing the course. For the most part, you'll demonstrate mastery of learning objectives by answering quiz questions. We'll have quizzes on a weekly or sometimes bi-weekly basis that cover several of the learning objectives. Students have told me they much prefer having multiple small quizzes, like a weekly quiz with 2 or 3 learning objectives, than having 3 or 4 really large tests with a lot of information on it. So that's what I'm going to do this semester. You will have at least 3 opportunities to demonstrate mastery for each learning objective. So if you don't get a question right the first time you see it on a quiz, you have a chance to try it again on a future quiz. In most cases, you can actually have more than 3 opportunities, but there are some learning objectives where I just don't have enough different questions to give an unlimited number of tries. The first 2 learning opportunities for each learning objective will be offered on a schedule. When you look at the timeline, you'll see which objectives are covered on each quiz. So each objective will appear in that schedule at least twice. If you need additional attempts at a learning objective, you have to schedule those with me individually. If you're really struggling with a topic, then I don't want you to feel obligated to make that 3rd attempt until you feel you're ready. However, I may limit the number of retakes you can make to 5 per week. To the extent possible, I want you to have all the time you need to really learn the material, but it doesn't work logistically to have a student try to complete like half the course in the last few weeks of the semester. A few of the learning objectives will be assessed through homework and lab submissions rather than quiz questions. So if you go to the course webpage and look in the navigation bar, you'll see learning objectives. So this document is the list of all the learning objectives. You can see here which ones are marked cores and which ones aren't. But you'll also see that some of the learning objectives have superscripts by them. For example, FC2 here has a superscript of H. That means that I'll assess this learning objective through a homework rather than having it be a quiz question. There are a handful of others down here. I'll let you look through the list on your own. Some of them are also marked with L's, which means you'll meet that objective through something you do in lab as opposed to a quiz. Down here at the bottom, you can see the key for those different superscripts. During the course, there'll be 4 projects. Each project's grade will have 2 main components. First, it has to pass my tests. In other words, it has to work. Second, it has to be presented and explained well. For example, if you're building a circuit, the circuit diagram needs to be neat and commented and understandable. Also, some projects have additional presentation components. For example, Project 1 requires you to analyze the circuit's propagation delay. All 4 projects cover fundamental course topics. Therefore, just as with the core learning objectives, the expectations here are quite high. But remember, you're allowed to keep working on a project until it meets expectations. So running into a problem the night before a project is due doesn't doom your overall grade. But if you get stuck, you got to keep working through it. You can't just give up and turn in a half-completed project. All right, now on to labs. Here's the first thing you need to know. Lab attendance is not optional. I don't like having to put this in the rubric, but students have been abusing it. You need to be in the lab, during the lab time, working on the lab. Labs aren't homework. They're designed to be challenging exercises that will stretch your thinking. I expect that you'll run into problems and have questions during the lab. So if you're trying to do this on your own, especially on your own outside of lab, it'll take you twice as long and be twice as frustrating. And honestly, this course is already challenging and time-consuming enough as it is. Remember, the most efficient way to get labs done is to first read through the lab the day before. Make sure you know what the lab is about. Make sure you have any software you'll need ready to go, either on your machine or in the EOS lab. And just kind of start thinking about the topic. Get the wheels turning. And 2, do the lab in pairs during the lab time. Many of the lab activities are designed to generate discussions. That just doesn't work if you don't have a lab partner there to discuss things with. Now, like most everything else in the class, you do have opportunities to revise the lab as needed, so achieving the required number of M's shouldn't be onerous. I'm not saying it'll be easy, but it shouldn't be ridiculous. Quick word about homework. Homework is the one thing you don't get a second chance on. This is because once I've collected the homework, I want to be able to discuss it in class and then post the answers on my office door. Once I've posted the answers, there isn't a whole lot of point in collecting it anymore, right? You can just copy the answers off my door. But to compensate for this relative inflexibility, the expectations are much lower. It just needs to be clear that you've put a reasonable amount of effort into it. Obviously, I don't expect homework to be perfect because it's just practice. But I do expect you to do it. Also, I'm willing to overlook a few missing homeworks. This is intended to cover all the typical cases. You get sick, your car doesn't start, the roads are bad, you have a big project due in another class so the homework doesn't quite get done. Right, if this happens once or twice, it really isn't a big deal. It's just part of being a student. But it's not okay to be missing a large chunk of your homework. And so that's what's covered by the rubric here. Now, throughout the course, I want to be as flexible as I possibly can with due dates. One of the key motivations for mastery grading is affording students the time they need to master topics. However, notice the rubric does impose penalties for excessive lateness. In a perfect world, I could give you all the time you need to do the work, and I wouldn't need this row in the rubric at all. But we don't live in a perfect world, right? There's 2 issues. One, if this course had no deadlines whatsoever, but all your other courses did, then I would end up on the bottom of your priority list, and a lot of the stuff just simply wouldn't get done in the course. That's just human nature. And second is the logistics I mentioned earlier. I just simply can't handle having too much work come in at the end of the semester. There just aren't enough hours in the day to grade everybody's quiz questions and projects and labs and all of that in the last few weeks of the semester. So I do need to make sure that there's an incentive to keep the work coming in at a steady pace. Realize, however, that these late days are cumulative. That means the more things you submit on time at the beginning of the semester, the more flexibility you have later in the semester. Finally, notice that the rightmost column gives the criteria for earning an A-, not an A. In order to get an A, you also need to do well on the final exam. The purpose of this policy is just to make sure that those who get an A actually remember most of the material and didn't just cram it into their heads the night before the quiz and then promptly dump it. All right, 2 more things and then I'll wrap up. First, the textbook. The official textbook for this course is the 2nd edition of Digital Design and Computer Architecture. That's the book with the green cover. This is one of the few textbooks that's actually worth owning. I know there's a lot of garbage textbooks out there in computer science, books that you buy and never open and so on. But this book follows what we cover in the course very closely and has some very good explanations about what we're doing. So it's definitely worth your money to buy. But I suggest you buy the 1st edition of the textbook and not the 2nd. That would be the one with the blue cover. The content is nearly identical. I'm only aware of one thing in the whole textbook that's different between the two. There's probably more, but I really only know about one. And it's much cheaper. You can find them for like 15 or 20 bucks. And this textbook is definitely worth that 15 or 20 bucks. So do go ahead and take a couple extra days to order a cheap copy of the 1st edition online. I'm not going to make you need the textbook in the first week or 2 so you can do that. No need to pay the big bucks for the green version at the bookstore. Second, I want to encourage you to use the Piazza discussion board. So if you go back to the main course page, there's a link to Piazza here. And this is just a discussion board. So if you have questions that aren't personal questions, so if you have questions about homeworks or projects or due dates or whatnot, you can post them here. And the nice thing about posting them here is that anybody else in the class can answer them. So if you're working on your project at 2 a.m. in the morning and you have a question and you post it to Piazza, somebody else will be up at 2 in the morning who can answer that, whereas I won't be. You'd have to wait for me to get up to get an answer. I also find it really helpful because if you have a question, you're almost never the only person in the class with that question. So when you post it on Piazza, I can answer it once and everybody can benefit from that, as opposed to me answering the same question 5, 6, 7, 20 times over email. Obviously, if your question is personal in nature about grades or something like that, email me, don't put it on Piazza. But other than that, please make use of the discussion board. Thank you for staying with me all the way to the end of this rather long video. The first video is also long, it's about a half an hour, but after that I made a concerted effort to keep the videos to about 10 minutes. A few get longer than that, but not many. Okay, so please take the time to watch those first 5 videos, even that really long first one, so we can hit the ground running on Monday. If you have any questions, please post them to Piazza or email me directly if necessary. I'll see you all Monday.